Okay, so let's just jump right in. How in the world does a character from The Simpsons, a kid famous for eating paste and saying I'm in danger, end up as the inspiration for a totally game-changing AI software development technique? It sounds like a joke, right? But it's actually one of the most interesting things happening in AI at this very moment.
So it all kicks off with this just wild claim from a Y Combinator hackathon, shipping 6 entire repositories of code overnight with one AI agent. I mean, that's a level of productivity that sounds like it's straight out of a sci-fi movie. It definitely gets your attention and makes you ask one really simple question.
Yeah, exactly. How is that possible with the tech we have right now? You think it must involve some super complex, next-level AI that we haven't heard of yet, but the real answer is, well, it's surprisingly, almost comically simple, and that's what we're going to unpack right now.
So let's get to the heart of it. This incredible technique is called the Ralph method, and yes, it is named after Ralph Wiggum. So let's take a look at what it actually is.
At its core, the Ralph method is all about being stubborn. You take an AI coding agent, you give it a task, and you stick it in a loop that just runs and runs and runs. The AI tries, it fails, it hits a wall, but then it just rereads the instructions and tries again. It does this relentlessly until the job is finally done.
And get this is the actual code. Seriously, it's not some crazy, complex algorithm, it's a single line you can type into a terminal. This little loop basically says, hey, computer, forever and ever, I want you to take whatever's in this prompt file, feed it to the AI, and just do it again. The genius is in how simple it is.
Okay, now this is where it gets really, really clever. This concept of being deterministically bad. What on earth does that mean? Well, it means you know the AI is going to mess up. You expect it to fail. But because the whole process is so simple, its failures become predictable. And if you can predict how something will fail, you can make a plan to steer it away from that failure.
So the big question is, how does this simple loop that's designed to make predictable mistakes actually build complex software? Well, the secret isn't about diving in and fixing the AI's code. It's about getting better at writing its instructions. Let's use an analogy to make this super clear.
Imagine you tell the AI, our friend Ralph, to build a playground. He goes off and builds a great one, but comes back with a scraped knee because he jumped off the top of the slide. Now, the old way of thinking would be to go into the AI's code and try to fix the slide logic. But with the Ralph method, you don't touch the code. You just add a new rule to the instruction file. You put up a little sign that says, slide down, don't jump. On the very next loop, Ralph sees that new rule and boom, he gets it right. You stop being the coder, you become the playground supervisor, just adding rules until the behavior is exactly what you want.
And this just shows you how powerful this technique really is. We're not talking about small fixes here. The developer who pioneered this is using it to create an entirely new programming language from scratch. The AI is building the language, and then it's learning to code in that same language, even though it was never part of its original training. Just wild.
That's absolutely mind-blowing from a technical standpoint, but what does this mean in the real world? For businesses and contracts? Well, the financial side of this is maybe even more shocking.
To put this into a business context, check this out. An engineer was taught the Ralph method and immediately put it to work on a freelance contract. Now, this was a pretty decent gig. The initial value was $50,000. And the final cost to deliver that whole project? $297. I'm going to say that again. From $50,000 down to under $300. Just let that sink in. This isn't just a small efficiency gain, it's a complete earthquake in the economics of building software. So naturally, this leads to a really crucial point. If the tool is so incredibly simple, where does all this value come from? Well, it comes from the person running the loop. It really is a matter of skill. And this brings us to the core philosophy behind the whole Ralph method. Large language models are mirrors. That's it. If the reflection you see, the output you get, is flawed, the problem isn't with the mirror. It's a direct reflection of the instructions that you, the operator, gave it in the first place. This slide right here lays out the massive shift in thinking that's required. The old mindset is to say, ugh, this AI is so dumb, it made another mistake, and you blame the tool. The new mindset, the Ralph's mindset, is to ask yourself, okay, how can I improve my instructions so that it never makes that specific mistake again? You stop being a code fixer and you become a prompt tuner.
So let's bring all this home. The really big idea here is that we're moving away from blaming our tools and moving towards mastering them. It's all about tuning, not blaming.
So, to wrap it all up, let's go over the most important things to remember. First, the Ralph method itself. Just remember, it's a dead simple, persistent loop that lets an AI work on a problem over and over again. Second, the process. You succeed by tuning the prompts. You're not a mechanic fixing an engine, you're a guide giving it better and better directions. Third, the mindset. You have to believe in something called eventual consistency, basically having faith that if you keep refining your instructions, the AI will get it right in the end. And finally, the whole philosophy. The AI is a mirror. Its performance is a direct reflection of your skill as its operator.
If your brain is kind of smoking right now trying to process all the implications of this, but at the same time you feel like you just peeked into the future, well, you're in the right place. Go ahead and subscribe to VibeDoc. We're here to give your mental software regular, fascinating upgrades just like this one.
And that leaves us with a final, massive question to chew on. As these methods get more popular, are we watching a fundamental change in what it even means to be a programmer? Is the future less about knowing the syntax of a specific language and more about the art and science of crafting the perfect set of instructions? Definitely something to think about.